space, you marvel at the huge amounts of space and how big things are in the universe.
In this video, we will show you that the science of atoms and molecules is just as easy to marvel at as the universe.
Atoms, or the basic units of elements, make up matter. This is a simple diagram of a hydrogen atom. The nucleus is where the protons and neutrons of the atom are stored. Depending on which atom it is, there will be a different amount of neutrons and protons. In a hydrogen atom, there's one neutron and one proton. This ring around the nucleus is where the electrons orbit. Most diagrams of atoms are misleading because atoms don't actually have a ring like that around the nucleus. The electrons just rotate around it very quickly. If a more complex atom has more electrons, it will have more rings as well. The hydrogen atom only has one electron, as you can see. When an atom does have more rings, there's a limit to how many electrons can be on those rings. On the first ring, there's always 2 electrons. On the second, 8. On the third, 18. On the fourth one, there's 32, and so on if they have more rings. On the last ring, or the valence ring, an atom is always desperate to get 8 electrons, no matter which ring is counted to be their last one. Going back to the hydrogen atom, this atom's last ring is actually its only ring. Just to make it clear, the nuclei of atoms are not nearly to scale as the models shown. If it was to scale, the nucleus would not be visible. In fact, if the valence ring was the size of the moon, the atom's nucleus would be about the size of a penny. In other words, the majority of an atom is empty space.
You may be wondering, how many atoms are there? Well, right now, scientists have discovered 118 of them, and they are all organized into the periodic table of the elements. Each element is a different type of atom, hence why an atom is defined as a basic unit of an element. Dmitri Mendeleev was the creator of the organizational system of the periodic table. Here are some of the patterns used to organize the atoms. The groups are numbers and they go across. The periods go vertical and they tell you the number of rings an atom has. Everything left of the staircase is a transition metal excluding hydrogen, and everything to the right is a nonmetal. Metalloids run along the staircase. Atoms are also organized by families. 2 of the most important families are the noble gases and the alkali metals. Transition metals are known for their ability to conduct energy. Some periodic tables show you whether the element is a solid, liquid, or gas, while other ones, like this one, don't. Here's the element carbon. The atomic number shows the number of protons and electrons in an atom. And then this number, which is usually a decimal, is the atomic mass of the atom. In order to find the number of neutrons an atom has, you subtract the atomic number from the rounded atomic mass. The reason that the atomic masses are usually decimals is because most atoms have isotopes, which are the same atom with a different number of neutrons. An example of an isotope is carbon-13, which has 7 neutrons instead of 6.
Yes, the atoms on the periodic table are all of the atoms known to man right now. The reason you don't see things like wood and water is because different atoms come together to make different substances or compounds. They combine and form ionic or covalent bonds because when an atom doesn't have 8 electrons on its valence ring, it is desperate to find them to become chemically stable. For example, sodium with 1 valence electron wants to get rid of it. Chlorine, desperate for an electron, comes along. Their needs match perfectly, so they exchange an electron. Because chlorine gains a negatively charged electron, the atom's whole charge is now negative. Sodium lost a negatively charged electron, so its charge is positive. Opposites attract, so the chlorine combined with sodium, creating salt.
Some families on the periodic table are more chemically active than others, like the halogen family right here. That is because they have 7 valence electrons. The noble gas family, right there, is the only family that is not chemically active because it already has 8 valence electrons. What makes an atom chemically active is the number of valence electrons that they have, because they always want to get 8 electrons. It makes them seek other atoms to combine with so that they get 8 electrons. Depending on which atoms combine, their bonds can be different. A compound that only consists of nonmetals is called a covalent bond, and they share electrons instead of exchange them. A compound that consists of a metal and a nonmetal, like the one we demonstrated, is called an ionic bond because they only exchanged the valence electrons.
When different atoms and compounds are combined, chemists and scientists write them out in things called chemical equations. If you were to combine N2 with H2, the reactants of the equation, and the product of the equation was NH3, this is what the equation would look like. Only problem is that the reactants don't match up to the product because, as you can see, the number of nitrogens, for example, is 2 on the reactant side and 1 on the product side. You could change this by balancing the equation and putting numbers before the reactants to balance them out with the product. These are called coefficients.
We are going to balance this equation as an example. Because there are 2 nitrogens on the reactant side, we need to make sure that that's true on the product side as well. So we need to put a 2 before the NH. That turns the number of hydrogens into a 6, so we have to also make that true on the reactant side. So that means that we have to put a 3 before the H here. The way you find the number of this type of atom is multiplying the coefficient by the subscript, which is the number below the symbol.
Thank you for watching!